In this example, we are going to use the function f of x is equal to 4x to the third minus 6. And we're going to do 3 parts here. The first part is to find the derivative of f and evaluate it at x equals negative 6. The second part, we're going to find the inverse of f of x. And then the third part, we're going to find the derivative of the inverse and evaluate it. So let's work on part A first here. So if I find the derivative of f of x, I bring the 3 and down in front, that's 3 times 4 is 12x, and then I decrease that exponent by 1, so that's a 2. The negative 6, when I take the derivative of that, is going to be 0 because that's a constant. Now we have to evaluate this derivative at x is equal to negative 6. And so I'm going to plug in negative 6. And when I do that, I'm going to get 432. All right, for part B, we're asked to find the inverse of the function. So to do that, I'm going to first rewrite the function. So I have y is equal to 4x to the third minus 6. And then I'm going to work backwards and undo all these operations and solve for x. So to solve for x, I'm going to add 6 to both sides. Then I'm going to divide by 4. And then I'm going to take the cubed root of both sides. So that will give me my x. And another way to write that, because we're going to use this in a little bit, you can also write it like this, where you raise it to the 1/3 power rather than take the cubed root. So all of this is equal to x. That's my inverse function. Now, in part C, we are asked to find the derivative of the inverse and then evaluate it at f of negative 6. So let's first find the derivative of the inverse. Now there's 2 ways that we can do this. We can directly find the derivative because we have it here. I know that my derivative is my inverse. My inverse is y plus 6 over 4 raised to the 1/3. So if I take the derivative of that, I'm going to take the 1/3 down in front. I have my base stays the same on the inside. I decrease my exponent by 1, so that becomes a minus 2/3. And then I have to multiply it by the derivative of what's inside. Now keep in mind that y plus 6 over 4 can also be written as 1/4 y plus 6 over 4. So when I take the derivative, I'm just going to get 1/4. Now to clean this up, I'm going to have 1/12 times y plus 6 over 4, all raised to the negative 2/3. So there's the derivative of my inverse. Now the question asks us to evaluate that at f of negative 6. If I look back up here and I find the value for f of negative 6, that means I'm plugging in negative 6 and for this x right here. So I'm going to take 4 times negative 6 to the third minus 6. That's going to give me a negative 870. So if I evaluate this at f of negative 6, then what I'm going to do is I'm going to plug in negative 870, what we found for f of negative 6, in for our y. And when I evaluate that, put it in on my calculator, do some work, what I'm going to get left with is 1 over 432. Now I'll label this as method 1. That's if we did it directly from the inverse, find the derivative and evaluate it. Now the other way that we could do it is using that trick that we learned, or that theorem in this section. If I want to find the derivative of the inverse, what I could do is I could take the reciprocal of the derivative and plug in the inverse. This is another way you can do it, but we should still get the same thing. So, let's see. So I'm going to take 1 over, if I take the derivative of f, that's up here, the derivative of f, we said was 12x squared. So underneath here, I'm going to take the reciprocal, and I get 12x squared. But we're not done, because the theorem says, not only do I find the derivative and take the reciprocal, but I have to plug in and replace, everywhere I have x, replace it with the inverse. So I'm going to rewrite this. Instead of putting an x squared here, I'm plugging in the f inverse. And then squared. So this was x, but remember we're using composition function here and plugging that in here. So this would be the derivative of the inverse. Now, we still have to plug in f of -6. So if I evaluate this, let me do this. If I evaluate this at f of -6, if I plug that in, I get 1 over, it's going to be a little messy, but it actually is going to simplify very nicely. So I'm going to, and for this x right here, I'm going to substitute f of -6. Now look what we have here. We have the inverse and we have the original function. So these undo each other. Just like if you were to take the cubed root of x cubed, right? The cubed root and the cubed undo each other. So what you're left with is just the -6. So you're going to end up with 1 over 12 times -6 squared, which is 1 over 432. So you get the same answer as what you got when we did the derivative directly from the inverse. There are times that one will be easier than the other. So this trick is basically just another tool that you have in your toolbox to use when you're taking derivatives. Sometimes one way will be easier than the other. So you just pick which one you think would be easier.